Um, Alright, so today we're going to carry on with Pong, part 2. Um, in case you got stuck in the part 1 video, um, and you might not have seen it, in the description there is a link for the source code so far. So you can go through that and make sure, if yours is not working, you can just make sure that the code's written the same. Um, if you haven't seen part 1, you probably don't want to watch this one without watching that first, because we're quite a way into it. So watch that first if you haven't, and then come back and carry on with this one. For everyone that's done part 1, we're going to carry on with the game today. So far we've got the ball bouncing around the screen, we've got the player 1 bat on screen, and we can move it up and down with the keys. There's no hit detection on the bat yet. It's just bouncing off all sides of the screen for now. So I think maybe the first thing we should do is, for now, if we just stop it bouncing on the left and right, ready to set up the hit detection. So for that we're going to have to come down to the move ball function, and if you remember, it's the X axis which is going across the screen left to right, so that's causing the left and right bounce. So instead of reversing the ball X speed, we'll get rid of that, and what we'll do is we'll just set ball X to canvas width divided by 2, and that will put it in the middle of the screen. So if I quickly control save and in the browser control refresh, so every time it goes off screen it comes back to the middle. Now if you've just lost the point and the ball's coming straight at you, I wouldn't say it's necessarily fair. So we might as well actually just put that ball X speed back in to reverse the speed. Ball X speed times equals -1, and now every time it goes off screen it should change direction. Perfect. So now we can start thinking about the hit detection on the bat. Now we could write the hit detection as part of the paddle logic in here. However, it's going to be bouncing off 2 paddles at the end of it. So rather than write it twice in each paddle, it's probably a better idea if we write it once in the ball and then we can use it for either. So we're going to use another if statement to create the logic. So if ball X, so this is where the ball's going to be on the horizontal axis, we want that to match the paddle, and not just the paddle's X coordinates. If you remember, the X coordinate is in the top left corner and the ball's going to be bouncing off the right hand side. So we're going to say if ball X, and we're not going to say equal to, because remember we had problems with that on the bounce. We're going to say if ball X is less than paddle 1X, and now we need to get it across to the edge of the right hand edge of the bat. Currently we're on the left, so we're going to add the paddle width. Save us doing any complex math. If that happens, then inside the if statement let's just say ball X speed, same with the bouncing, times equals -1. Now send it back the other way. So currently we're only providing an argument for the x-axis, so what we should see is every time it comes in line with the bat, it's going to go back the other way whether we hit it or not. Okay, so next we need to, for the hit logic to be more believable, we need to now add some logic for the y-axis. So we do 2 ampersands after the logic we've already written. So whereas these two lines up here say or, if this condition is true or this condition is true, with the AND operator, we're basically checking that both the conditions need to be true for this logic to apply. So we're going to say if it is at the edge of the paddle and it's within the top and bottom of the paddle. So we can actually put a new line here to save space and just kind of put our X and our Y logic together. If ball Y is greater than, no, that's less than. If ball Y is greater than paddle 1x, and so that's the top of the paddle, and if ball Y is less than paddle 1x plus paddle height, then bounce. So let's just refresh that and see what that's doing now. Hopefully if we miss it, it resets to the middle of the screen. If we hit it, okay, that's not bounced. Okay, there's something wrong with the logic there. Okay, I can see what I've done is my ball Y is checking itself against the paddle X. So that's just a silly mistake, which these things are normal for programming. So now if we refresh that, first we'll check miss, that's working. Now we'll check bounce, that's working. Okay, it doesn't really look like the ball's bouncing off the bat. It looks like it's bouncing before the bat. I think that's mostly to do with the frame rate. Sometimes it looks like it hits. But what we can do there is, before we reverse the speed, we can quickly say ball X equals paddle 1x plus paddle width. So that will line it up at the moment it bounces with the paddle. I don't know if you're going to see a massive difference on here depending on how YouTube sets up the frame rate to this video, but it looks a bit more like a convincing bounce to me now. Okay, there's still some issues with this. So if you saw it bounced there on the bottom corner, but if I come down to the top corner, which is probably going to be quite hard to do, it goes past where it would have bounced. So I would have considered that a hit. No. What's the easiest way to explain this? So what's happening is we're comparing the hit detection from the top left corner of the bat and the top left corner of the ball. Now if you match those two top left corners up, the ball is going to be inside the top of the bat. But if you do it for the bottom, if you match the top left corner of the ball up to the bottom of the bat, the ball's going to be sitting just underneath the bat. So on one end we've got hit detection not going far enough, on the other end it's going too far. So what we can do now, for the top half, we could subtract from there and we want to put this in brackets so it does this part of the calculation first. Ball size divided by 2. So it's basically going to give us an extra half of a ball to hit the ball on the top side of the bat, and we can literally just copy and paste that. So the minus and the brackets, Control C, Command C on Mac. I'm actually going to put this bit of logic on the next line down again, because we're getting quite a lot of logic there. I'm probably going to bring that back as well so it stands out from the code inside the loop. So I'm going to paste that onto the end here, and again we're going too far over on this end, so subtracting will bring it in a tiny bit. So if we're down here, imagine we're going to subtract it, so we're here, and on this side we're right here, so for that to be equal we can subtract the same amount to bring it here. Okay, so quickly save that, refresh it, make sure everything seems okay. There, so I can hit with the top corner of the bat now, it's a bit fairer. And with the maths we've used, it will be the same on the bottom. There is a glitch, if I can find it. Oh no, I fixed the glitch already. So this is interesting. I made this game a few times, so I was anticipating it. But if I comment out, not that one, if I comment out the bit that puts the ball on the edge of the bat, and save that, refresh the browser, oh, can't catch it. Okay, so it trails up the bat because the X coordinate is inside of where it needs to be to bounce, and when it does bounce it's still inside, so it's just constantly being sent backwards and forwards in that gap. That's why we, over here, we're setting it to the right hand side of the paddle, so that now it doesn't get caught in that dead space. Oh no, it still does. Oh, it's because I haven't refreshed it. So by sending it to the right side, it can't get caught in the space where it keeps getting sent backwards and forwards. There we go. That would have sent the glitch through, but we fixed it now. Alright, excellent. One thing I've just noticed is we're still able to go off the screen with our bat. So let's fix that. So that would be on the move paddle. So we've got the logic there for up and down. I believe in the last video we came into a problem where something was going forwards and backwards at the same speed in each direction, and it ended up staying still. We can actually use that to our advantage here. So if paddle, is it 1x? Yep, if paddle 1x is less than, let's not make it right on the edge of the screen. We've got a 10 gap on the back. Let's replicate that black gap on the side, and it'll kind of frame the game a little bit. So if paddle x is less than 10, then paddle paddle 1y is less than 10, then paddle y speed, is that correct? Nope. Okay, I've confused myself, bear with me a second. Okay, alright, there's no paddle y speed. we're doing paddle 1 Y. So when it's going, oh sorry, the sun's in my eyes. So when it's going up, it's minus equals 10. And when we want to give it the opposite amount of speed, so we'll say plus equals 10. And same for the bottom. If paddle 1Y is greater than screen dot height, and we want to make sure the same gap's there, so minus 10, then paddle 1Y minus equals 10 to give it the same amount of force backwards as forwards. And if we refresh that, refresh inside the browser, great. When we get to the top, even if we're holding the key, we can't go further. We can on the bottom. What have I done wrong there? Paddle 1Y is greater than screen dot height. Oh, it's not screen, it's canvas. Getting confused between Python and JavaScript. And refresh the browser. Still not working. Very strange. So paddle 1Y is greater than canvas height minus 10. Then paddle 1Y minus equals 10. Oh, yes, of course. Excuse me. Alright, so I've just explained it for the hit detection with the ball and bat, and then completely forgotten about it with the bat and the canvas. So it is stopping, but stupidly I forgot to include the paddle height in my math, so let's subtract paddle height. Control save, control refresh. There we go. That was embarrassing, but that's programming, so alright. So we've got hit detection. The ball can now go off the screen. The bat's listening to the edges of the screen. We can add the second paddle, but before we do that, I think I'm just going to just tidy up the bounces, or make sure they're tidy. So like we did the ball bouncing off the bat, for the edges of the screen, we can set the ball Y to where it needs to be. So now this condition is checking both top and bottom. So we're going to have to check bottom and top individually to put the ball in the right place. Because if we write this for all of it, then if it hits the top, it'll end up at the bottom. If it hits the bottom, it'll be at the bottom. Whichever way round we write it. So we're going to nest an if statement inside. In fact, we're going to nest two. One for the top, one for the bottom. And we can keep these on one line. So let's say if ball Y is less than, and we need to put this in before we change the direction. So if ball Y is less than canvas height minus ball size, then ball Y is equal to canvas dot height minus ball size. So that makes it on the bottom, it makes it match up. Now we can do that for the top. So if ball y is less than 0, then ball y equals 0. That was nice and easy. Alright, so save that, refresh, everything should still work as before, the bounces should just look a little bit cleaner. Yeah, perfect. Okay, let's add the second bat. We're going to need some variables for it. We don't need to do paddle height and width again, but we will need to do the x and y. So there, paddle 2x, and we want it at the edge of the right edge of the screen, so it'll be canvas.width, but because of the order we're writing our logic in, we're not defining canvas until we get down here. Even though technically window.onload is the first function to run, the script has still kind of taken note of all of the variables before it gets to that. So we can't use canvas.width here. So if you did want to change the width of the canvas, you'd have to come back and change this variable accordingly. We could have it as a blank variable and reassign, but that's all a bit complicated for what we're doing. So we'll just use the width, which is 800 here. And what we'll do is, we could do the maths ourselves. What's paddle width? 20, and we want a 10 gap, so it would be 770. But we've got a computer, so let's use the computer. 800 minus 20 for the paddle width. Again, we can't use that because that's defined after this one. And minus 10 for the 10 gap over here. There, paddle 2y, set it the same as player 1, 200. We'll need to put up and down in for paddle 2, but let's just worry about drawing it for now. We've got enough in there to draw it. So if we come down to draw all, right down near the bottom, put a comment in so we know what it's doing. Draw paddle 2, and it's color rectangle function, and in fact we can just copy and paste this line because that's all the same. That's Control C to copy, Control V to paste, Command on a Mac, and we just simply change paddle 1 to paddle 2 on the X and Y. Hopefully if we save that and refresh this, there we go, we've got a second bat there. There's no hit detection yet, it's not moving yet, it's not got artificial intelligence yet, AI. So we might as well put the AI in first before we start worrying about the bounce. So this is AI, it's this is like the easiest AI you're probably ever going to write, but it's still AI. You've made a computer think once you've written this. So what have we got? We've got move paddle 1, and we need a move paddle 2 function. So we're calling a function that doesn't exist, so let's write it. Function move paddle 2. And what we're going to do, we're going to get just to chase the ball. So we're going to write it like really basic and build from there, I think, rather than trying to write everything perfectly first time. So again, just another if statement. If ball x is less than, so that would, oh no, ball y, we're chasing the ball's y coordinate. If ball y is less than, so that would be above. If ball y is above paddle 2y, then if the ball's above you, you want to go up to follow the ball. So paddle 2y minus equals, the other bat's moving at 10, let's keep it fair. And with that same logic, if, put a line down so it's easier for you to see, if ball y is greater than paddle 2y, then we want to go down. Paddle 2y plus equals 10. Alright, that should actually be enough. Let's refresh it, see what happens. There you go, it's chasing the ball now. Okay, so it's going off the screen like our paddle was originally. So what we can do, if we go to our paddle 1, move paddle 1 function here, we can just copy and paste these two lines. So Control C or Command C on Mac, and then if we put those few lines into this block, and just make sure you're changing all your 1s to 2s. If we save and refresh, it should respect the borders now. There we go. It can't go further than the borders. Alright, already we're getting some quite good logic. Okay, I think to chase the ball down to every single coordinate is a bit unnecessary. So we'll change that, but before we do that, I've noticed it's lining the ball up to the top left, so that's an easy fix. If ball y is actually we can fix both of those in one here. If ball y is less than paddle 2y, and how big's the paddle height? Let's say if it's less than paddle 1y plus paddle height, I'm going to divide that by 2, put that in brackets though, or else it's going to do weird math. And if it's less than paddle 2, if it's greater than paddle 2y, we want to measure it from the same point for now. So again, inside brackets, paddle height divided by 2. Right, so now it should match it up to the middle of the paddle rather than the top left hand corner. Does it look right? Yeah, that looks perfect to me. It's chasing it pixel for pixel, which I don't think it needs to. So I'm gonna make a new constant for paddle 2, and I'm gonna call it reaction delay, and I think 30 should be alright. So what this is saying, we're going to say if the ball is, I use the left hand back so it's not moving, if the ball is within this middle region of the bat, don't follow it. You don't need to keep chasing it if it's like between here and here, because you're already in line with it. It'll make the movements look a little less computerized, because there'll be moments when the ball bounces off the edge of the screen, the bat will stop moving. So we've created a reaction delay constant because we don't want that to change. I'm going to come back down to move paddle 2, and I'm just going to subtract the delay reaction from the final math and add it to the other line. Hopefully I've done that the right way around. I haven't spelled reaction right. Let's try that. No, there's something wrong there. Delay reaction, maybe I typed it wrong up here. Oh, reaction delay. Delay reaction delay. There we go. It doesn't chase it pixel for pixel now. It'd be more obvious as we see it bounce. You see it waits for a second before it continues the chase. What next? I think the bounce. We're going to put hit detection on the second bat. So we already had that in our move ball function. Nice and convenient. This one's nice and easy to do. So Control C, and then underneath it, let's even comment these just so we know. So hit detection paddle 1, hit detection paddle 2, and to comment is just 2 slashes. Now on the second one down, just like before, go through and change all your 1s to 2s. So paddle 1 is paddle 2, paddle 2, paddle 2, paddle 2. I think that's correct. Let's save and refresh. Oh dear. Oh yes, okay. So there's something I've overlooked here. I'm just trying to figure out what it is. I have an idea of what it might be. The sun's getting very bright. Oh, okay. We're already on the left corner, so that's one thing that's already wrong. We can get rid of the paddle width. Ball X. It doesn't need to be paddle width there because we're going on the left hand side. So save that, refresh. It's still something incredibly wrong. Ah, yes. Okay. Excuse me. So, because it's on the right hand side, we need to flip the logic round for the ball X. So, we were just basically seeing. So, on this one, we trigger a hit once it gets to the left side of the where it needs to be, because the bat's on the left. So once it's gone left far enough, it goes right. This bat on the right, we were asking it a second ago. Change it back. Apply the logic when the ball's on the left of where it needs to be, and because the bat's on the right, the ball's always on the left, so it's just stuck over here behind the bat flashing. So that's a less than. We need to change that to greater than. So now if ball X is past the X coordinate, then go back the other way. So save, refresh. There we go. That was a little bit embarrassing, but there you go. Alright, so the ball's moving. We've got hit detection for player 1 and 2. It looks like the ball's bouncing off the inside of his bat. Yeah, it does. So where before, when we reassigned the X for the left paddle, for the right paddle, we're making it equal to ball X is becoming equal to paddle 2X. which is putting the ball inside the paddle. So let's just say subtract ball size from that one. So that's how far left we want it to be. We want it to be the size of the ball. Should be a cleaner bounce now. There we go. Starting to look like real Pong. What are we missing? We're missing scores. We're missing a net down the middle. The game's really easy, so we're missing anything that makes the game harder. So it's constantly going at a 45-degree angle in many directions. So the way the original Pong used to play, if you hit it on certain parts of the bat, it would get faster or slower. Make the game much more fun to play, especially for two players. So once we finish this game, you could even remove the AI, make a copy of this file, cut out the AI, and try and replicate the player 1 controls with some different buttons for player 2, and you can play this with your friend. Or if you're like me, you play both players with one hand each. Because I don't have any friends. Alright, what are we doing? We're going to make the ball fly off a bit more when it hits certain parts of the bat. So here's the hit detection for paddle 1. What are we saying so far? We are saying if the ball is this far along the screen, and if it's within the top and bottom of the bat, then bounce the ball and make sure the ball bounces from where the paddle edge is. Don't make it bounce inside the paddle. So we want that to occur always. Whatever logic we write now, we're going to have to put here. So we could say if it's at the top of the bat, make it fly off that way. If it's in the middle of the bat, make it fly that way. So what I think I'm going to do, I'm going to say if it hits this top corner, increase the speed to send it up. So if it's coming down like this, if you hit it really well in the corner, you can send it right back. In fact, there's an easier way to do this. If we let's not worry about that logic statement there. What we can do underneath ball speed X, we can use something called delta Y. So it's basically just going to work out how far it is from the top or the bottom. Okay, so yeah, we're basically just subtracting the ball's Y from the Y position of the middle of the bat. So the greater the difference, the higher this number is going to be, if that makes sense. So if it's right in the middle of the bat, it's going to be zero change. So now we've got that number, we've figured out the difference between the two points. If we do ball y speed equals delta y times 0.35. Alright, so now when you hit up the top and bottom edges of the bat, it should increase its y speed and make the game a bit harder to play. Doesn't look like it is. Did I even refresh it? Control save, control refresh. Oh, I've only put the logic in for one bat, that's why. And I'm doing it on the opposite bat. Control C. Paste that in there. I've just realised I've done it for player 2 there. And I spelled speed wrong. Okay, save that. That should work this time. I'm surprised we didn't get an error for that. That was everything wrong there. There you can see the ball's flown off up. There we go. He's not going to get that. If he gets that, he's moving too fast. Oh, you got me. Okay. Right, so part of making a game is testing a game. Sorry, you got to watch me play. I'm getting beaten. Yeah, I got one. And you can see he hit in the middle and it sent the ball just back with no arc. Alright, maybe I think I might have the paddle speed up too high here, because we seem to be able to catch that ball quite easily. So we're just doing 10 at the moment. That's bad practice. I shouldn't have done that. Let's put a new const here with the paddle height and paddle width. Const paddle speed, so it's fair, and start with 6 because 10 is definitely too fast. We come back down to move paddle, paddle speed. In fact, we'd be smarter to just copy that word and then paste it into the bits where we changed the speed. Right, assuming I've done that right. Yep, they're moving slower. Maybe they're moving too slow. Yeah, they're definitely moving too slow. Anyway, you can play with the numbers to get it right. Let's try 8. In between where we were and where we are. That seems a bit better. Okay, so that's changing the Y speed. We could change the X. Okay, this is a shot in the dark, but if multiplying it makes it go one way, and maybe dividing it will make it go the other way. So if we hit it in the middle of the bat now, it will go faster on the X range. We need to put that in for both. Control C, Control V. I've just pasted that into the second paddle as well. Whoa. It looks like we're playing really fast, but it's just not resetting the speed when it hits. So that's definitely wrong. What if we try dividing it by 3? If this don't work, I'm just going to leave the x-axis. Yeah, I think that looks a bit fairer. Yeah, cool. In fact, let's make it... I feel like it speeds up too fast. Nope. 6 done the opposite of what I wanted it to. Whoa. Oh no, times in by 0 point something is dividing. And I'm just doing it for one thing again, aren't I? Times 3. How long we got left? Another 10 minutes? That is not working at all. Alright. I give up on that. If you figured it out, email me and let me know what you did. And then I'll put it into my code. So I'm just trying to get it to go faster on the x-axis if it hits in the middle. Okay. Alright, one thing that's definitely not happening is when the ball gets reset to the middle, it's keeping its speed. So on the piece where the ball gets sent to the middle, which is here? No. It's in the move ball function. Ah yeah, ball X here. Alright, so what we also want to do there is, in fact, before we put the ball back in the middle, we can just reset the speed. So ball X speed, and what did it start off as? 7. So ball X speed equals 7, ball Y speed equals 7. Right, so there's a lot of bounce, and then there's a normal angle. Alright, and I got a point, look at that. I think it's probably about fair to think about writing some kind of score mechanism. And then we can draw the net, and then that's a working game. Alright, there's not long left, we've only got 10 minutes left, so for now we'll just do the scores in the console log. So what do we need first? We need to count scores, so put it in after the paddles and before the keys. So their P1 score, so that's player 1, equals 0, start off with none. Their P2 score equals 0. So when the ball goes off the left side, which is in our move ball logic, so where are we checking if it goes off the left side? Here. Nope, that's ball Y. Here. So we're checking both, aren't we? Alright, so here we're checking both situations. Now again we need to split that up to each individual situation. So make a bit of space, write a new if statement, and we've got to do one for each side. So if, again, if ball x is greater than canvas dot width minus ball size, then P1, because that would be us scoring a point if it's gone off the right side, P1 score. I remember the shorthand for adding 1 was plus plus. And then if ball x is less than 0, then P2 score plus plus. So that is basically just a line inside curly brackets, but because it's such a short bit of logic, I've just put it all in one line there. Now we could save that and refresh, but we've got no way of accessing the scores. So the scores are going up, but we don't know what the scores are. So in the update all function, I'm going to console.log player 1 plus P1 score, and then plus now this should make a new line, \n, should put on a new line. It's gone pig, so it's obviously an escape character. Player 2 plus P2 score. Right, we save that and refresh that. Hopefully in the console log down here it will tally our score as we play. So let's give him a point. There we go. So 2 points to player 2. I've got a point on that hit for sure. Yep. There we go. There's our score working. So next time we will, if we just have a quick look at what Pong's supposed to look like, if you haven't already. Now you can see it's pretty much what we've got. What's a nice one? Let's go with the original. That one. Oh no, that's YouTube. Get off there. So what we've got here. There's our bats. We've done those. There's the ball. We've got those. We are counting the scores, but we're not displaying them onto the screen, onto the canvas. So we only know the scores because we're using the console log. Anyone playing the game would have no idea. There's a net there, we can put that in, and we can also, I think we could get all this done on the next session, we could put in a win condition. So if you get to 4 points or 5 points or something, then you win, and then the game starts again. And then at that point, when you've got controls, an objective that can be made harder, and a win condition and a lose condition, you've basically finished a complete game. So hopefully one more session, at most 2, depends how much we want to fancify it, but we're definitely going to put this net in, because that's a good opportunity to learn a special piece of code called a for loop, which is very, very handy to know. And I think we'll write our own font rather than use a built-in font just for fun. Alright, awesome. See you next time.